Completed?
Answer 25, madam. 28.
28. It will be varied by. What is sigma FD value? Is it minus 200 or not?
No, it is 300, madam.
300. How it comes around 300? What are the M values you have? 5, 15, 25, 35, 45, 55, right? So F values you have 5, 10, 25, 30, 20 and 10. Then what is minus D values? Tell me. Minus 30, minus 20. Is it correct?
Ma'am, FD value is minus 200.
Yes, FD value is minus 200. That's what I am saying. Just correct it, ma. Do it correctly. FD value is minus 200 only. See, D values are 0, 10, 20. Then FD values are 3. See here, F into D you need to multiply. Just take F and D values. Minus 30 into 5, 3 5 ja.
150, ma'am, minus
20 into 10, it will be minus 200.
200.
Then it will be minus 250. Then next one is 0. Then you have 200. 10 into 20. 10 into 20 is again 200. So how much it will be? It will comes minus 200.
33. Ma'am, X bar is 33.
Yes, good. X bar is 33. This is the answer. Just correct it. All of you just correct it. Just pay attention while calculating whether it will be minus or plus. So that is the confusion, right? So you may vary your answers. Then you have only one more method under this one. So are you finding out the differences between direct method and shortcut method? Direct method, we are taking classes or x values or variable values directly. And in case of shortcut method, we are taking midpoints. And one more difference is we are calculating what? Small d, right? In case of shortcut. And one more important thing, we have step deviation method. See ma, while doing it is very easy. But after completing whole this arithmetic mean, it may get some confusion. So you need to write very clearly. You have to mention in your notebooks. See here. This is the way to calculate direct method. This is way the uses of this shortcut method, and the final one is step deviation method. So just come to this step deviation method. In this method, all of you should write down a point. In this method, class intervals are taken into consideration. Class intervals are taken into consideration to simplify the calculation. To simplify the calculation. Here we are taking directly the class intervals to simplify the calculations. This is true for equal class intervals. This is true for equal class intervals. However, in case of unequal class intervals, one can further simplify the calculations by taking a common factor common factor. What it is telling us, generally in our data is having some, what are that? Class intervals, right? So if you have an equal class interval, that will be of 10 to 20 or 30 to 40 or 80 to 90. What is an equal class interval? Seema, what about the difference between these two, lowest limit and highest limit? It will be around 10. So here we have equal class intervals, right? See here, the difference will be a 10. If we have an unequal class intervals in our data, that will be 10 to 10.5, or you have 9 to 11, or you have 3 to 1. In such cases, you need to select a common factor. Common factor. So while doing problem, how you can select your equal interval or unequal interval, how it will be, you just see by doing the problem only. Okay. So first you just remember this point. Just remember this point. You have to write it. In case of equal class intervals, one can further simplify the calculation by taking a common factor instead of the class interval. So just write down the formula for this. X bar, that is arithmetic mean, is A plus sigma f of d dash. Sigma f of d dash divides with sigma f, which will be multiplied with I. This is small I, ma. This is small I. So what is the difference you observed here between the continuous series of shortcut method and this step deviation method? Here we have small d, sigma f of small d divides with sigma f. This is the formula for your, what is that? Shortcut method. So here this is d dash. This whole term is multiplied with I, small I. These two only the differences what we observed here. The calculation of arithmetic mean in a continuous series by using step deviation method. So just write down, small a is assumed mean and small I is class interval. Small I is class interval. D dash is, small I is class interval, right? D dash is deviations of midpoints from assumed mean. From assumed mean. That will be m minus a. Deviations of midpoints from assumed mean divides with I. So previously what we used to take, small d is deviations of midpoints from the assumed mean, right? Here we are going to calculate d dash. So for that the formula is m minus a divided by I. Just write down m minus a divided by I. Here I is the class interval, m is the midpoint, a is the assumed mean. Are you clear, everyone?
Yes, ma'am.
Yes. Yes. Just write down one problem. Calculate the arithmetic mean from the following data. Arithmetic mean from the following data. Plant height same, centimeters, or classes, you just write down. Then midpoints, then variables, then small d, that is m minus a. Next, d dash, that is m minus a by I. The last one is f into d dash. See ma, the data will remains the same as before problem. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. So what are the midpoints you got in the last problem? You just write it down. 5, 15, 25, 35, 45, and 55. Then the frequencies are of 5, 10, 25, 30, 20, and 10. So I think so we have D values already, right? So just copy it from the last problem. Minus 30, minus 20, minus 10, 0, 10, 20. What I am writing is right or not?
Yes.
Yes, ma'am.
Then calculate D dash. And one more important thing. What about I here?
10, ma'am.
Yes, it's a 10. Class interval value. These all classes will be present in a equal distribution, equal class interval. That will be a 10. Do it, D dash values. First one is how much here? These three values will be minuses. Minus
3,
3, minus
2,
2,
minus 1,
minus 1,
next
0,
next
1, 2.
2.
2,
Next FD values, FD dash values.
minus
Any one of you.
Minus 15,
Hmm.
minus 20, minus 25, 0, 20, and 29.
20 and 20. So how much it will be? Sigma FD dash
Minus 20.
minus
Minus 20, ma'am.
minus 20. Just substitute in the formula. X bar is equals A plus sigma FD dash divided by sigma F into I. Just do it. How much it will be?
$33, ma'am.
33 only. Why? Because the data was same, but here we are using different methods to calculate arithmetic mean. Am I right?
Yes.
Yes,
Yes.
ma'am.
Either it may be a shortcut or it may be a step deviation or it may be a direct method. We can able to get the answer is same. So these are the series arithmetic mean calculations for various datas. And till now we have seen three different series, no? Individual, discrete, continuous, for calculation of this arithmetic mean. And you have only one different kind of problem, that is, just write down calculation of simple arithmetic mean series, simple arithmetic mean series having open end classes, having open end classes, open end classes. In some cases, just write down, in some cases, the lower limit of the first class, the lower limit of the first class interval, first class interval, and the upper limit of the last class interval are not known. Not known. Okay. See, ma'am, in case of previous problems, we have different classes intervals, right? So that is 10 to 20. What is our data? Sorry, 0 to 10, 10 to 20, right? Here we have taken the data like this. So in the previous problems, so here we have a lower limit and here we have a upper limit in our class. But in some times they won't be present any lower limit of the first class and higher limit of the last class. In such cases, what we need to do? Those are called as open-end classes. What we need to do? Based upon the remaining intervals, we need to calculate our ends. See here. For example, your data will be number of pots, number of plants. Suppose the data will be below, first class will be below 10 and the second class will be 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Likewise, it will be 50 to 60. And the last class, they used to given as above 60. So what we need to do? We need to calculate as usual our arithmetic mean. How we can take the class interval? See here, what is the difference between all the rest of the classes? It will be a 10. So the first class will be below 10. So how we will take here the class interval as 0 to 10.
0 to 10. 0 to 10.
And the last interval will be 60 to
60 to 70.
70. So based upon the remaining class intervals, we need to first assume our classes, first class of lower limit and the last class of higher limit. Then we have to put it our data into whatever the method. Okay. So this is one different kind of data. That is nothing but open-end classes. So this is what your entire mean. So from this, our mean will be completed. So I will give some exercise problems in your WhatsApp groups. You all can do from that. Okay. If you have any doubts, ask me for next class. Okay, ma? Is it clear or anyone is having any doubts?
Nothing, ma'am.
Nothing? Okay, just leave the class. Leave the class, ma.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Send me the attendance too.